Okay, so in this video we're going to talk about the concept of maps and plugging them in Maya, some of the things that you have to think about from a beginner's point of view, covering all the different areas. So even if you are familiar with them, you might pick up something different that you didn't initially know. To start this off, at the very beginning, the concept of a map is very similar to the concept of a map as we know it to this day. Maps are essentially chunks of information broken up and displayed in a 2D manner. For 3D, it's not that much different. We're still taking different areas of a surface and breaking it up either by color or by other types of data. So this could be something like a difference in reflection. It could be how shiny or not shiny that reflection is, areas being metal, glass, etc. So maps are a way of breaking up just information and applying them in different ways. Now, just like you would have different maps in this idea here, where you could break up them based on regions that people live in, or continents, or you could break them up in terms of weather, climate, general type of flora and fauna, etc., etc. You can break these up in various different ways. So maps in 3D are broken up as well, and often they start from the point of view of UVs, which can be very simplistic, where you look at it and you can easily tell what each individual zone is in the UV map, versus complex, where the UV map doesn't really tell you anything, and so we need to look at other ways of breaking up these different zones, and this is where the concept of things like ID maps come in, where ID maps use different colors to allow you to quickly isolate these zones. Now in this example, it's still fairly tidy, but it could be applied to this more complex version as well, where every little tiny chunk that was green would be one type of material, and another chunk that would be red would be a different kind of material. So these could be metal, and this could be like a blue painted, sparkly kind of thing, and this is, you know, a glass region here, and so on and so forth. And so by breaking these up, we're breaking them up into different areas of material types. So these are still relatively simplistic in terms of how they break up, even though it could be based on this. Now there is another way where things can be broken up, not just within, let's say, like this red area. Let's say this red area was rusted metal. Well, I have a zone which is, all of this is that one material, but that material itself is not really just one material. It's actually multiple materials. It's more like two materials. So if we just clear the canvas here and drop something like that on there, we look at this and we have different zones. So even if this was just a nice simple square panel of a wall that was metal or something like that, or a sheet of metal, we have these zones which are going to be the actual shiny metallic portion of it versus, say, the rusty portion of it. And the rust is going to have different properties. Metal will be somewhat shiny, highly reflective, have a different color, and the rust area will not be highly reflective, at least not in a metallic type of way. Color difference will be there, and it's not really shiny either. So we have these two different zones that we have to break up. So it's not just about grabbing a chunk of the geometry and just applying color to it. We need to separate these. Now we can hand paint the separation between them, but sometimes we can lean on other tools, other elements that can help us break these things up. So if I just bring the layers over here and grab this, if I go to my channels, I'll notice that there are some distinctive differences between the channels, things that can help me break them up. Now sometimes these breakups between these channels can be really easy to separate, just based on the channel or just based on a simple color selection. I can go into Photoshop and say select by color and work with that. But in this case, it's maybe not quite that simple. I want to isolate a specific section, but if I look at this map here, if I look at the red, that gets brighter, but I might be missing something. There's something that's not quite right. I've got these areas which are a little bit brighter, which may pop up, but those aren't really red in color. They're just white. And I can't go with blue and just choose the black area, because I also have other areas that are essentially black or darker in color as well. So I need to come up with a way with finding just that zone. One of the things I can do in this particular case is I can use a difference map between these two very clear pieces of information. The green is kind of sitting in between and it doesn't offer me much, but the red does offer a distinct variation here, as does the blue region. So I'm going to grab this, Control A, Control C to select all and then copy it. Go back to my RGB and I'll just Control Shift V to paste it in place. And I'll turn that off and come back to my original image and grab another channel from it by grabbing the red channel. Again, Control A, Control C, return to the RGB, and Control Shift V to paste in place. So now I have these two different maps. I'm going to take this map and I'm going to set it to difference. And now it's isolated much more clearly the zone where the red exclusively lives. So just to make this a little bit nicer, I'll go ahead and Control E to collapse those together. And then I'll just simply go to an image adjustments levels and just tidy that up a little bit more to create that very distinctive and clear separation between them. Maintaining at least a little bit of range in between, so I do have a little bit of fall off that I can play with. Once I have this, I can use this as a selection by holding down Control, clicking on the channel here, and then what I can do is I can store this as a selection by storing it as an alpha, so that I can use this again and again. I can throw this away now because I don't really need it anymore, but if I deselect with Control D, going in here and saying Control click immediately allows me to select all the red rusty regions. So I can of course improve this. I did not isolate well enough some of these regions, but that's the essential idea, is using that to isolate just the red portions and get some control over it. This darker region here, where it's definitely sort of corroded, perhaps I can go into the blue channel and isolate some of that and get some even greater variation so that I'm not dealing with just one section at a time. Now I'm storing that selection this way. If I go back to this layer here and just deselect that, so look at my blue, and the blue is grabbing all of the dark regions. Control A, Control C, Control Shift V to paste in place, and then just going to image adjustments levels again. And just sort of boosting that again to isolate those sections where it's more rough. And that's an inverse of the selection, so I'm just going to Control I to invert that. And maybe I'll label this one red rust. Control click this one, store it, dark corrosion, and now that's been stored, I can throw that away. And you can see how that's isolating an area. Just to give you an idea of how I could then lay this out for selection purposes or breaking these things up into different zones, I'm going to create an area for a map. This area, let's say, will be my Metalness, or how about roughness? Let's do roughness since there's going to be some variation there. Initially, I will create 3 regions. Rust, rust, and my corroded, and my metal. Now, since the whole region here is essentially metal, I'll just pick a color. Let's maybe make it blue. So that's my metal region. For the corroded region, again, Control, click. And for this corroded region, I'll put another color. Let's put something drastic, so I'll go with perhaps green. You can see all the corroded area there. Now I'm going to apply the rust region. Go ahead and Control click, and I will apply another color. And since it's rust, why not just go with red? As a result, I can see these different zones clearly mapped out, much like the ID map that we've seen in the other portion there. Now with these different regions, I can go ahead and isolate them by saying I can't change the values outside of where values already exist. So if I were to go ahead and take this, you notice that I have no more selection. Control D here. There's no more selection currently active, but I've locked opacity. If I were to come into here and take something like the roughness value, which is currently at 0.1, and I wanted that roughness to be here, I would simply pick the value for that. Again, going to my color swatch, I would go ahead and choose like a white value, and the HSB B here is my value. Now, in here, we're dealing from a 0 to 1 value where we're going to 100%, so we're just going to have to change decimal places. So if we look at this, move the decimal places, this is basically a 10, so 10%. If I change this value to 10, then I know what's going to happen is that this value, when plugged into this area via a map, will give me exactly a 0.1 value because they match. Now that I've got this zone locked off, if I just Alt backspace, it will fill that entire zone with that color. By keeping these groups, these different isolated areas together, and then duplicating them, just by Alt and dragging to make another copy. This could be an area like pump map. And because this zone here would be rather bumpy, I could go and say filter, noise, add noise. Gaussian, monochromatic. Just have this other layer over top of it so you can see it. But you can see now I've got a whole bunch of noise in that region. I can do that again with this one. Once again, filter, noise, add noise, and maybe reduce it because perhaps it's a little bit less scratchy. I can even apply different filters like filter, blur, Gaussian blur, maybe not that much. I'm just going to desaturate that because it was based on green. And what you're seeing here is essentially a bump map that's been created where you You have extreme changes, subtle changes, and no changes at all. And I can save this now as a bump map. So by breaking up these different zones using opacity locking, I can fill them with distinctive values based on the sliders that I pull, and I test them first, see how that looks in the actual render, and say, that looks like a good roughness. That looks like a good metalness value. That looks like a good overall specular value, etc., etc., etc. Once I've established those, I can convert them into values and plug them into the zones that are relevant. So this is one of the ways that we can easily break these things up, and then just grab that section, file, save as, save it out as a PNG or some other format that you want to use, and there you have your bump map. And this one, let's pretend that we filled in the other values. And there would be, say, your roughness map, and so on and so forth. So what do we do now? What more do we need to pay attention to? Well, once we've saved out these different maps and we've done our testing, we want to bring them over to Maya. Here we have an AI standard surface. When I go to plug in a color and add a file, it will automatically connect the color output to a color chip. There's some things that we have to be aware of with regards to the settings of the file node. File node comes with a filter type to begin with. This filter is actually applying a subtle blur to the information that's here. It's resampling it. And each one of these different methods is a different method of resampling the values between each other. So when it scales it up and scales it down in the viewport, it will apply these methods to that image. If I set them to something like off, then it's going to use a method similar to what's called nearest neighbor. It's basically not going to adjust it. It's not going to do anything different to it. So this is a way of dealing with elements that seem to have lost their crispness. So if you load in an image and then you look at it and it doesn't just seem to have all the detail that it had before, you may want to change the filter type. Now, where this can go wrong for you is when it's zoomed all the way out and you're using something that is fairly high contrast, something with a lot of small details in it as well. If you turn the filter off in those cases, typically what will happen is that you'll get some dancing of the pixels. They'll kind of flit around because it doesn't know which pixels to choose, and it does update that information on a frame-by-frame basis. So if you're getting that kind of issue, there's two ways of dealing with it. Number one, you can update the filter type and choose something softer like a Gaussian or quadratic in order to smooth that detail out. Another option is, of course, switching to a lower resolution version of that texture. If, for example, you know that it's going to be further away from the camera for the majority of the shot, the ideal solution is actually using a lower resolution version of the texture. Because what happens there is it's not storing as much information in memory, and it's not doing as much processing to the image itself because there's less pixels for it to have to sort through and to try and eliminate. So if you know something's going to be far away, don't use a high-res texture on it. It's just a waste of time. If you do want to do some filtering in that mid-range because you're going far and near, but you don't want to lose a lot of data, you don't want it to soften too much, you can use something like the box filter, where the box filter does very little resampling of the image. It's a very simplistic filter, and so it maintains more of the original detail. But again, it is still prone to the same thing as off, where you can have sort of dancing pixels as it eliminates more and more on high contrast things. So if you want to maintain the sharpness, that's pretty much what you deal with. There's also the map method, where it's supposed to break it down at different resolutions automatically and then blend between them itself, and you can try that and see what happens, but that's another option that you can play with. And so it's a little bit of testing. I'm going to turn mine off for the moment. The next thing that I have to pay attention to is color space. Now the color space ultimately deals with what we call LUTs, or lookup tables. And one of the main issues in there is how it appropriates, or not, how appropriate it is to the data. The data that you're getting in, if it's a data map, should not be readjusted, because what it's applying is something called gamma. It's a gamma curve. If you're bringing in a color image, then you want to keep it in this mode right here, which is sRGB. Just to point out what gamma does, I'm going to go back to my image here, and I'm going to turn this off, and we're going to switch to my gamma layer. Let's turn these ones off here. So my gamma layer, if I do an image adjustments levels, we have this clean gradient here. And sRGB contains a gamma of 2.2. It takes the image, the original information, and it takes this darker region and lifts it. This looks more correct to our eye in most images versus the data that it received in the first place. Inside of Maya, saying something is sRGB says, I'm expecting this, but I want this, because this is how the software is going to do the math with regards to the light. The result is that it applies instead an inverse curve, which is 0.454. And so it adjusts that. And then it sends that information off to Maya. Now, if you had given this and expected this, applying sRGB means that Maya will send you this information, meaning values now are shifting. If they were white or black, they wouldn't change much. You wouldn't see any difference. And if they're very close to it, again, still that same idea. But if they're anywhere in those middle ranges, they will heavily shift. If you look at this mid-gray in this image has moved all the way up here, meaning the value is completely changed. This mid-gray is now actually a really dark value. So the idea here is that if you end up with a data map where you've picked very specific values, like when I pointed to saying, oh, here's a value of 1 that would be 100%, or a 0.1 would be 10% in Photoshop, then you should make sure that it is reading it correctly, which means as a linear value. That means you should switch to a linear mode. So you have two main options here in terms of most sRGB coded images. So one is the linear Rec 709 sRGB, which will convert it to a linear mode. Or you can just go ahead and switch to a raw format, which will load that information as raw, again being linear in nature. You cannot pick this value before you have selected your image, because by default, when you select an image, what will end up happening is it will go ahead and change this to whatever it thinks the mode is. There is a bit of automation there, but it's not necessarily always intelligent automation. It just goes based off the image itself and sees if there's some way that it can interpret the data, what kind of lookup table it should be applying. So what we need to do here is pick the image first, choose our filtering method, and then to go ahead and choose our color space. Now once again, I've plugged this into a color and it's worked out just fine. Let's see what happens if I plug it into not a color chip, but a numerical value. Something like this roughness right here. For specular, I want to control the roughness. Is it really shiny and polished, or is it rough? I'm going to create a roughness map. If I go ahead and click on this and choose File again, what you'll notice is rather than plugging in the color data, it's now plugging in an alpha channel. If I have an alpha channel on it and I thought to apply the roughness map to that, then that would be fine. But in most cases, often cases, you're making a black and white map or a packed map, which means you would have to manually connect these. There are two ways that you can deal with this. Number one, you can go into the color balance region and you can say alpha's luminance. When you click this, it says instead of using the alpha channel, use the luminance of the red, green, and blue channels. It takes these ones and evaluates them all together, getting kind of an average value for each pixel, and then applies that. The second option is going in and choosing a specific input and outputting it that way. If it's a black and white map, all of these individual channels will be the same. If it's a packed map, which is a very efficient way of dealing with things, you could have things like this R could be my roughness map, the G could be my metalness map, and something like the B could be maybe my bump map. All of these are black and white data, and they could all be packed into the individual channels one at a time, allowing me to load just one image instead of 3 individual images and wasting this extra data. When working in software like Unreal, Unity, and such, often cases this is the way that most people will work. They will have packed maps. When you export things from Substance Painter into an Unreal format, typically speaking, again, it will export packed maps. So it will take various different maps that it's generated inside of Substance Painter and will pack them into the red, green, and blue channels based on its own default methods. So, one last thing that we really have to pay attention to, and that is when I go to this, not all numerical values go to a value of 1 and stop. Many of these do go between 0 and 1 and function in that way. However, some other ones will go to values above 1. For example, this IOR, the index of refraction. How can I use values above 1 in these cases? Well, if I use a mode inside of Photoshop which supports that, such as image mode 32 bits per channel, what happens here is this will output a map which contains information above a value of 1. I believe we can go to a value of 20 in this particular case, which is more than enough for any kind of index of refraction, because I think the largest number I've seen in an index of refraction was maybe 4. So you could easily apply those values in there simply by being in that mode, and then in your color selection tool you have numbers here which you can input. This goes through an entire range. So I could go ahead and choose 4, for example, and then paint those values in there or fill those values into those regions. So if I did have different types of glass or materials that had different indexes of refraction, then I could go ahead and apply that to those different zones in that way. But that's only necessary for those where you do need to plug that in. So once you plugged that in, saving that out as either an HDR format or an EXR format, which support 32-bit data, you could then plug those in, and again, you could use something like an individual channel and plug that into the appropriate zone. So this is the basics of setting up maps and connecting them in the software. Ultimately, it comes down to isolating the zones that you need and applying the values in those areas, be they textural, color, or by numerical input, applying them to value. Keep in mind always that you do have to adjust your color space and also pay attention to things like filtering. So I hope this was valuable to you, and that's the end.